recording. All right, well, everyone who's on this call, thank you so much for joining us for the first CCB skills seminar of this semester. I'm really excited for this lineup, especially starting today with Giulia, who's a third year computer science student. Before I introduce her, I did want to just make two announcements really quick. The first one is that we have a little form that you can access right here that just gives us a little bit of feedback and lets us know how we're doing and if there's anything that you're interested in learning about in future seminars. And then the second one, for those of you who are just joining, is that we also have a website right here that you can use to refer back to this talk that we're recording, as well as any tutorials or resources that Giulia or any of the speakers have put together. And this is it's going to be cumulative over time, and we just started putting it together last semester, so we have all the talks and resources from last semester, but this semester will of course update it. Yeah, so those are the two little announcements. Just before you go after this session, if you can just fill out that form, it gives us lobbying power with the powers that be to keep this stuff going. Yeah. So with that being said, I did want to introduce Giulia, who's like I said, a third year computer science student at UC Berkeley. And she's given a talk today on high performance computing in with AWS, Amazon Web Services, which is something that she's quite an expert in. I can gather. She's a fellow in a special interest group in high performance computing. She's part of several labs associated with Lawrence Berkeley Lab, National Laboratories. And she's really interested in the intersection between high performance computing and computational biology. And it's at risk of totally butchering what exactly you're working on, but from what I gather, it sounds like you're working on distributed genome assembly from long read DNA sequencing, which is a super cool problem and really fits nicely at this intersection. Yeah, so hopefully you all learn about how to get started with AWS, especially for computational biology applications or just any application that you're interested in. And I'll be moderating, so if you have any questions, you can just put them in the chat and I'll save them for the end and we can go through and unless Giulia, you're comfortable with people interrupting you, but I'll let you make that decision.
Yeah, no, that's great. Thank you very much for the introduction, and that's great. I think that once I will share my screen, I won't be able to easily see the chat. So if you have questions, you can just raise your voice or ask Matt to do that. So that's great. So I'm gonna start and sharing the screen. So hopefully this will work out just nicely. You should be able to see half of the screen as the tutorial and the other half my terminal. Is that correct?
Yes, I can see that.
Okay, great. Okay, so I will first start with a brief introduction to how to use AWS in general, and I'm gonna have to thank David, that is like another student that did this tutorial like a few years back, because a lot of the material for the first part of the tutorial is something that he put together. So I have to acknowledge that, and then we will go into the second part on high performance computing. So first of all, you might have some different reason why you would like to use AWS. Like when I started working computer science, I was mostly using, my laptop, and it became quickly clear that that was not, an option anymore when you start to doing more serious stuff and, data set increased. And simply, if you have to, take a Zoom call while your laptop is running something, it just is not gonna go well. So for example, a few reasons you might want to use the AWS is because you need to run something for, a long time. So you cannot just keep your laptop open and running for that much. Or you need multiple processors at the same time. And, your laptop might not have enough core to do that. And the third is that you might require much more RAM than your laptop is available. Like my laptop, I think it has 32 gig of RAM, and that's hardly enough for the kind of job that I usually do. And it's, especially in computational biology, when recently data are just exploding. So there's literally no way you can keep all the data on your laptop and process your test data. And personally, I have also some other motivation to like be interested in the cloud. Like I mostly work on supercomputers, thanks to my advisor that both work at the Lawrence Lab. So we are associated with NERSC that have like, I think now it's like between 10 and 15 most powerful supercomputer in the world. Used to be higher a few years back, but yeah, so like I had the incredible opportunity of using supercomputers, so that's cool. The issue is that I see many colleagues and many collaboration also outside Berkeley that need that compute power but don't have access to supercomputer, because that's a whole like political and economical reason that it's outside the scope of this tutorial, but still like not everyone could have access to supercomputers. So being able to efficiently use cloud resources for high performance jobs, that would be great, and that's one of the things I'm interested in looking into. But yeah, so like except this brief motivation, you could try to think about cloud versus local clusters. So Berkeley, for example, have this cluster Sabio. What's the difference between a data center like for AWS or like other cloud providers and a local cluster? Well, the one of the advantages that is also a downside, depending on how comfortable you are, is the fact that you have full control over the servers. So you have sudo access and you can install whatever you want, like, and everything, and that's particularly great sometimes, and it can be annoying other times because you just have to put your hands on things that you maybe have never seen before. But as we'll see later, AWS usually provides a few basic images that we will see later what it is. So basically you will have already a whole bunch of software installed. So most of the time you don't have to start from scratch. That's nice. The other advantage of using the cloud is that you don't have to wait for your jobs to run. This can be partially true when you use clusters, depending if you use them in shared resources or not, but still usually the wait time is much smaller with respect to a local cluster or supercomputer. Like on NERSC on Corey, when I have to run some particularly big job, my program could stay in the queue for days, and that's sometimes annoying, even because that happens before big conference deadlines, and that's everyone wants to run 24 hours jobs on like 1,000 nodes, and it's just a mess. And the other advantage is that you have no limit in how much compute or like memory you need, except for the cost. So again, in the downside, we have the full control that can be seen as a problem sometimes, and the cost, meaning that you usually pay for what you're using. And this is one of the, it's like one big disclaimer that I have to do right now, is that if you're going to do this tutorial step by step with me right now, you're probably ended up spending between $5 and $10, like assuming that you will be very good at the end of the tutorials and shut down everything that has been need to be shut down, like VPC, network interface, gateways. We can briefly look at that at the end of the tutorial. So just make sure. I'm sure that many of you are probably associated with some lab that provides credit, so spending $10 is not probably a problem for those labs. But if you're using your credit card, it's something that you want to keep in mind. Okay, so first thing, we want to start and create an account if you don't have one. And for that, it's pretty simple. They ask exactly your email and your credit card. And if you're associated with some lab, you should ask that lab to give you like some kind of access code, or I think it's group code or something like that. In most cases, you can also get some educational credit. I think that the first time I was using AWS, I just registered and they gave me like $100. Of course, you have some limitations, so you can maybe get the most powerful instances and everything, but that was good enough for getting started. So once you have your account, what we want to look is like, this is your management console, and there are a whole bunch of services. So we have AC2, that is the main one, that is the compute part, that is the one that we mostly work today. Then you have F3, that is the storage unit of AWS. So like where you store all your data, possibly. Like a lot of companies just store their data there, even like genome sequencing data, and you can download them. That's pretty nice. And other two things that we won't go into the detail today, but we will see the VPC part at the very end when we'll try to shut down everything in order not to have extra costs that goes on for like months. That sometimes it's small thing like a few cents, but it's kind of annoying if you just get it running there. Amazon is doing a lot of money of people forgetting to shut down stuff. And the other things that is useful is the AWS Cost Explorer that basically is telling you, where your money is going. And what's surprising is that most of the time, your money is not going into compute. It's going into other stuff because compute is usually easy to remember to shut down and other stuff is more hidden. So it's not, but yeah. So if you look at the, as we said, like easy part, that is the main part, we're gonna click here. And you will see that in the top right, we have this Ohio, this a whole set of regions. And this is like kind of an interesting concept. Basically, this is telling you that AWS has a lot of different data servers like spread out across the world. And you can choose in which data center, in which server, in which region you want to use, create your instances. I'm not really sure why, but I always use the US East Ohio. Technically, you might want to pick the one that is closest to you. I never lived in Ohio, so I'm not sure about that either. But hey, let's say that we're going to use this one. And this is important because if you create one instance in Ohio, and for some reason I'm going to move to California, my instances are not going to be there. Like I have 0 instances running in California, but if we move back to Ohio, that is where I usually work, we'll see that I have 5 instances running right now. And this is sometimes creates some panic because people just, oh my God, I forgot, my instances got deleted. And it's most of the time you just logged into the wrong region. So just keep this in mind. The region concept. Then we can look at the instance volume and snapshots, snapshots and images concept. So instance is basically your servers, and what you're gonna create is like your compute part, your processor. The volume is the storage associated with your node. So basically you can compose your node the best way that can fit your data. And then you have a snapshot that is like a copy of your volume. So even if you're just saving that somewhere, so it doesn't get lost. And finally, the image concept that is very nice is basically, so like, let's say that you start an instance and you install your bunch of software, your GitHub repos, your work, but then you at some point you want to shut down the instance. You don't just want to keep running for hours if you're not using it. So what you can do is save an image of this instance with all your stuff installed and shut down the instance. So the next day or the next week you want to use that that set of like software and installation, you can simply create an instance starting from that image. So you're not going to lose anything, and you don't have to install repos or like import data every time that you start a new instance. And we'll see briefly how to create an image in a minute. So we can first go in our dashboard and create our first instance. So we will see that I already have a few instances running, and this is because we will see later when we are going to create HPC cluster that the creation of the cluster itself can take up to a few minutes depending on the size of the cluster. So in order not to just looking ourselves in the eyes for a few minutes, I created the cluster earlier so we can just access them. But now we're going to create a new instance so we can see how this is done. So if you click on launch instances, you will be redirected to this AMI page. And this is what I mentioned briefly at the beginning. So we can choose some of the kind of basic images that Amazon already provides. So you already have some software installed that you don't have to start from scratch. For example, for today's tutorials, we want to select the Ubuntu 18.04. So we select this image. And this is also has a cost. So keep in mind, if you're probably gonna use an image with a whole bunch of deep learning libraries that might have cost a little bit higher. So then you choose the kind of processor that you want. So in this case, we don't have to do much. It's just a tutorial, so we can select the T2 micro. That is like a single, basically a single core, very small memory, like very bad network, very low performance network. And we will see later when we look at HPC that, you know, this is definitely not what we want. Let me see if I can. So when I was doing some work last summer on benchmarking cloud performance, I think I was using something like, yeah, I think I was picking some CPU with like a way better network performance. That's crucial when, well, now I forgot how to move it. Okay, sorry.
Giulia?
Yeah.
Sorry, I have a question. Could you clarify what you mean exactly by network performance? Is this the speed at which you're able to interface with the cloud, or is this something else?
That's the speed that when you connect two different nodes, the speed that two nodes can communicate with each other. And that's crucial when you think about distributed memory algorithm. So if you're like, just consider a single node, that's not particularly like interesting. But when thinking about distributed memory algorithm, it's crucial to have a low latency network, because if you have many nodes and the latency to send messages between nodes, it's high, that's basically, you know, your algorithm can be super good, but if that's slow, you're not gonna go very far.
That makes a lot of sense. Thanks for the clarification.
Of course. Yeah, please, you know, like if there's something that is not clear, just stop me and ask questions. So, okay, so in this case, we don't care about you know, network performance, or we don't have to do any particularly heavy computation. So we are just gonna select the T2 micro. Okay, create a subnetwork. You might create a subnetwork. I don't know why this is happening, but we are gonna do that. I'm gonna use the default one. This is me deleting a lot of stuff to avoid paying extra money. And then I deleted some probably default stuff. Come on. Can you just give me whatever I can? Okay. Okay, let's do something else. So this is usually should not happen. Usually you have a default subnet. I probably deleted something when cleaning stuff yesterday. So what I'm gonna do now is, let's see if I can create, why this is the amazing part of doing stuff live. Can you just pick one? Oh, come on.
Yeah, this kind of stuff can almost be more helpful because you can see
what
kind of snags you hit.
I'm not, I mean, like, it gives me a whole bunch of, you know, IP, and it says that none of them is fine. So I'm not sure exactly what. So this is the default one. If I just pick this, is this what you want? Okay, maybe it's this one. Okay, so if this happened, you know that you can probably use the IP that is giving it there. Let's see. Okay, now we have one, so let's go back. So we were in EC2, and we wanted to create an instance. Okay, let's look again at this one. Micro. Well, you're using that. Are you fine? Well, so this is a whole, let's see if we'll be able to create this instance. But so this is a whole bunch of settings that you can look at. So One common one is specify the CPU option. So in this case, we have a single core and a single thread per core, so there's not much we can do. But when you have, bigger processor, you can choose how many cores to use or how many threads per core to use for that processor. And the other common option that you might want to look at is the tenancy. So in this case, we're going to use shared, and by default is shared. So it means that you might share that with other users. And usually we do not want this when doing HPC job, because that's something that, in HPC, we are particularly worried about performance and reaching the best performance. So we usually prefer having dedicated instances for ourselves in order not to have other people using what we are using. Of course, there is an extra cost, again, tied to this one, but yeah, just so you're aware, depending, like if you're not doing HPC or performance characterization work, you're probably just fine with the shared version. Cloud is doing much better with multi-tenancy in the recent year. At the beginning, like 10 years ago, multi-tenancy was like a problem, meaning that it was impacting performance quite a lot, but today's cloud is doing a pretty good job and performance are not that impacted. Okay, so next part is the storage. So this by default is 8 giga. Let's say that we know that we have to save a lot of data, so we can increase it, for example, and have it to 50. Then you can add tag if you want, just to, if you are gonna create a lot of them. Oops, typos. You can just do this or not. It's not needed. Same for the security group. So in this case, we are just gonna use the default one, but in the tutorial, there is an appendix at the very end on how to use, how to connect Jupyter Notebook or RStudio through AWS. And to use that, you need to add a couple of security groups in order to be able to connect that. And everything is explained in the tutorial. I just don't think we had enough time to go through that, but it's everything in this appendix, and there is also my email at the end, so you can just contact me whenever you have questions. Okay, so now we are ready to start our instance. You will need to select a key. So in this case, I already have one key. If you don't have one, you're gonna create a new one. What happens is that it will create a new one, you will download it, and then as it's mentioned in the tutorial, you might need to change the permission of your key in order to be able to use it before accessing your instance. So in this case, I already have my key and we are ready to launch our instance. And we can see it here. Let's see, view instance. Okay, is this pending one that is being created? So this might take a few seconds. Usually creating a single instance, it doesn't take a long time, but this is a great moment for question, if there's any.
Yeah, we don't have any questions coming in the chat, but if anyone has any questions about the workflow and getting up the EC2 instance, feel free to just either chat it or speak up.
It might be already ready. Okay, so let's see. Now that it's up and running, you can click on connect, and what you will have is basically already okay. Also here you can see that you might need to change your permission if that's not already changed, and this is the command to connect. Let's see if it works as it's supposed to. Technically, yes. Let's see. Come on. If this is annoying at the beginning, then you kind of get used to it and you start doing other stuff while all this stuff, is up and running. I swear I tested this multiple times. Let's see. One thing that we can look at in the meantime that this gets up and running is the cost explorer that I mentioned earlier. So this is particularly nice to look at how you're spending your money and to keep track of, if there is stuff that you thought was shut down, but it's not. So for example, you can see how much you're currently spending this month. And this is not much. Okay, this is timeout. So let's see what happened here. Oh, it's still initializing, that's why. Okay, so no panic. So you can see, the breakdown. I've been spending a bit more money on January when I was first getting started with this one. February, not much. And then yesterday again, because I was trying this, and probably sometimes today, this will go up. Last summer, I was working on HPC, like supercomputer cloud comparison, and the costs were much higher. Because in that case, I was running big job for a lot of time, and especially using, beefy instances and a lot of nodes. So the costs were much higher. But usually if you're just, using medium scale nodes and single nodes, it's not going to be too bad. And again, most of the time you will have someone paying for you. So that's also good. Let's see if this finished. Okay, let's try again. Maybe yes, maybe no. Okay, so there might be something going on here that I'm not exactly sure. So let me, yeah, go ahead.
I was going to say, maybe you can show us what one of the other instances looks like if you log on to one of the other instances.
Yeah, exactly. I was going ahead with, yeah, exactly. We can totally do that. Oops. Okay. And we can log into, so like, let's see if I can. So if we do this, technically we are just connecting to the master node. So this is working to the master node of one of the cluster I've been creating. Then I will show later how you can, log into the cluster itself, that you need a separate tool. So right now what happened is that we are just access the master node. It is also T2 micro on the EAST2. So once we are, and in this case is also like Ubuntu 18 AMI. So let me see. If we go back to the tutorial, we can like just use this instance to do a few basic stuff. So one thing that you might need to do, so now we are at this point where we created, we SSH into our instance. And a few things you might do is to like, install softwares. I'm not gonna do it right now because it might take again a few minutes. And given how this tutorial is going, I don't wanna risk other other problems live, but this is, for example, just installing Python 3 to do your computation. And once you have installed your software and potentially your repo or whatever things you want to install, you are ready to create your image. So the next time you will start this instance, you don't have to start from scratch. And to do this, you can go on, select your instance on the EC2 main page, and in action, you will have image and templates and create image. You can enter an image, a name, and again, and you can associate also volume with it. And once everything is ready, this is gonna create an instance, an image that you will see here. And once it's created, basically, the next time you wanna create an instance using this, like image that you create with your software and repositories, you can go on the AMI page and select the instance, and then in action, you will have launch. And this command will send you over to the launch page where you select your AMI, when you select, sorry, your kind of instance and the storage and security group and everything. The advantage is that instead of selecting the plain Ubuntu image or some other, basic image, you will have already your data and software associated. So this is pretty nice. Now we can go on the beefy stuff. So in order to be able to do HPC on AWS, you have to download this AWS Power Cluster. That is very nice open source cluster management tool that AWS released in 2018. And this makes our life much easier, because before this you had to set up everything by yourself, and it was really messy. It took a long time and very error prone. So setting up a cluster was very hard, but this software make it very easy. So this is a few instructions on how to install it on your Linux or Mac machine. There is a support that is experimental for Windows, and you can follow the link here. And if you are going to install it, I would suggest to follow this tutorial instead of the main page, because the main page basically tells you do this and do this, and you won't understand why things are not working, because there is this middle passage of installing AWS CLI that is not well advertised, in my opinion, on the tutorial. So it might take you some time to figure out why your installation is not working when it's missing a little piece. So once you have installed your software, what you want to do is check if everything is right. So in this case, now we went back and AWS. And you can check if the installation works. So this is promising. And then once everything installed, you want to configure your cluster. To configure your cluster, you will need to have access to what is your access key and your secret access key, that you can get them from, so going on your username and clicking on security credential, access key, and you can create them. I cannot do that because I already have two, but you create new access key, and what happens is that it will automatically download a CSV file with your access key and secret access key, and that's what you will have to add here. Based on the kind of permission you have, if you are within an organization, you might not be able to do this. If you're not, you might need to go back to your admin and ask to give you permission. If you're just using your own account with educational credits, then it should not be a problem. But sometimes when you're for an organization, they don't give you this kind of permission. Okay, so we have already the access key and the secret access key. Then you can select your region. In my case, I always have Ohio. Output format is not needed, so you can just disregard that. And this is the main part, and this is the AWS configuration. Then you have the second part, that is the actual configuration of your cluster, where you decide the number of nodes, the kind of workload manager that you want to use, and everything. So it's nice to also use the option, let me see, it's config and you can choose the name of your config, because by default it will save in config, but this is kind of annoying if you're trying to create more cluster at the same time. So it's just nice if you can just give a predefined name. So this happens. So the first stuff is, again, you can choose your instance. I always go with Ohio, let's say your region, in your key, that is the one that you need to access. And then the third point is the kind of scheduler that you want to use. So I will show 2 examples on how to use Slurm and AWS Batch, and that's mostly depend on what you are more comfortable with. For MPI, if you're using MPI, that is message passing interface, that is a kind of programming language in distributed memory. AWS Batch seems to be the one with more support on AWS side, but this is really up to you. For example, when I started, I was mostly using Slurm because that's what I have, like there's on Cori and NERSC, so I was just familiar with that. And again, you can select the kind of basic operating system. We're going to select Ubuntu, and then here you select the number of nodes that you want. We can choose 2 and a maximum of 4 because there is some potential you can use. You can use the what's the name? Like elasticity factor of the cloud. So basically, if you need more compute, you could add 1 node at runtime and reduce it not. And then you can select the type of instance for the head node, and usually you can select something like not particularly powerful. Then again, it depends on how many nodes you have to handle. In this case, we can T2 micro. I think I usually have M4 large for the master node. One maybe like if you're doing HPC work, you might want some more beefy node for the compute part. But again, in this case, it's just a tutorial, so we don't care. But you can just put the name of the instance. Then you can ask for the automatic VPC creation, and we say yes. Let's see if this works. And then you can select if you want the head and compute node both on the public network or not. I usually go for having the compute fleet on the private subnet, but that's pretty much up to you. And this, what happened is that it's configuring your cluster. And this again might take a few minutes. So right now what we do is that we jump on one of the cluster I already created. So once this is completed, this is the kind of command that you want to run. So create cluster and the name of your cluster. And again, this is going to take a few minutes, and also then the creation of the actual cluster is going to take a few minutes. So what we do now is that we log in one of the other cluster that I previously created. And let's see, okay. I might not be able to go through both examples, but everything is on the tutorial. So now we are going to log into the Slurm cluster I previously created. Okay, this works, so this is already a success. And we'll see how we can run our first job using Slurm. So in this case, so this is a bunch of commands. You can see using sinfo, you can see the kind of compute that you have connected to the cluster, and there and they ignore the list. And this, you can use this when running MPI jobs with Slurm. You will have to define the IP address of the compute node. While for AWS Batch is a bit more convenient because it does that by itself. So in this case, we can just look at a simple job. So if we create a hello job sh, we can see how to use Slurm. Hello job. We're just gonna copy and paste this one. Okay, so to submit a job using Slurm, you just do batch hello job.h.
I think you had a P instead of an O accidentally.
Okay, that's good. I was already worrying why this is not working. Okay, that happened. It's submitted. And we can check with SQ the status of our job. In this case, we told the job to wait for a little bit. So, and this is your whole bunch of information. You can keep asking SQ. At some point, we don't see this anymore. And this is because it will already have finished the compute. So let's see. You will have this output file that is still empty because we told it to wait for 30 seconds before running something. So, and now if we open the output file, we'll see hello world from compute. So this is mostly, how to basically use LARM. Now I want to go briefly on the MPI part using AWS that is probably more interesting, but one thing is that you can also use LARM to run MPI jobs. If you have questions and you are more comfortable with LARM, you can just send me an email and I can show you how to use LARM for MPI. One important stuff is that you can exit your cluster using exit, and remember to delete your cluster when you're finished. So this case was LARM cluster. And this is also gonna take a little bit, so delete without the R, so, okay. Now, we can move on the other cluster. So in this case, come on. Okay, I'm already in. In this case, I call it AWS batch cluster instead of LARM cluster. So, and this is exactly the same, but in this case, we are using a different scheduler. So the way you look for jobs and you run jobs is a little bit different. So in this case, you will have a few different commands. This is just a bunch of commands that you can find online easily to see, if you have jobs running, if you're waiting, what's the name of your compute nodes, and so on and so forth. So now to look at how to run MPI, here's a few indications. So we want to create an MPI file, first of all. So we will have this MPI hello world job, and we can just copy and paste this nice piece of code here, where nice is arguably, but okay, so we save it, and now we want to have this submit MPI. So this seems a little bit more scary instead of LARM, but the good part is that it does everything by itself. So you will need to modify very few parts in these submit jobs. Admittedly, I prefer LARM, but that's what AWS suggests for MPI. So that's a little bit up to the user. It's just a matter of getting used to the kind of syntax of the job scripts and everything. So what we have here is basically a whole bunch of commands that will take your code, they will compile it, and we run it on the compute nodes that you have connected to the cluster. And again, the command, it depends. So in this case, we're going to tell it to run that code, hello world, on 2 nodes. So we can submit it, and if everything went well, you will have something like this that tells that your job identifier, this is this one, has been submitted. And you can watch with AWS bstat and AWS bstat all the status of your job. So basically runnable, it means that it's ready to run, but it hasn't started yet. Then you will have running, and then you have complete. And you can monitor and keep seeing this might start or might start very soon. And you can also kill a job that you're not more interested to run using AWS bkill. Then while we wait for this to run, and in the last 5 minutes, I would like to do a little bit, talk a little bit about the placement group and performance part. So right now we have seen how to run some basic MPI job and distributed memory using AWS batch, and it's possible to use LARM as well. And, most of the time you might be, happy with this, but if what you need is really performance for whatever reason, you want to pay attention to 2 things. And first, as we mentioned at the very beginning, is the network performance, meaning that the latency between the compute nodes needs to be as low as possible in order to achieve good performance. And the second one is this placement group concept that AWS Power Cluster gives you. Basically, you can add that manually to the configuration file, meaning that when you just do P cluster configuration, it's not going to come up as an option. So you have to open the config file manually and add that up. And basically you just do placement group and you will have a few different options. And usually what you want is cluster. And basically this guarantees that your instances are physically close together. And that's, of course, guarantees like lower latency because the wires between the nodes are shorter. So for like literally physically point of view, that will be better. Of course, if you're using thousands of nodes, there's no way that you can have thousands of nodes in the same rack, but you want to maximize the proximity of the nodes together. And so let me see. And I just wanted to show, so this piece of work might be or not interesting to people, but I did some benchmarking later, like earlier last summer, and the results we found, I think were pretty nice. So basically what we saw, and this is particularly interesting in the point-to-point dependency and latency. So in these two plots, what we are looking is at the latency between two nodes on AWS and Cori system, that is the supercomputer. And what's super nice is that historically supercomputers have been always way better than the cloud in terms of network performance. So cloud have always had many advantages. You could have potentially newer hardware and bigger processors, but the problem of doing HPC on the cloud is that the network performance was bad with respect to the supercomputers, and that always limited using clouds for HPC work. But recently, we can see that so in the bandwidth, higher is better, and in the latency, lower is better. Cloud, so the two AWS instances, the green and the red here. I'm sorry for colorblind people, probably green and red is a bad choice. Is doing much better. And one hypothesis that we have when doing this work was that the whole deep learning wave and the need for distributed memory work and GPUs, multi-GPU jobs kind of push the cloud to improve their network performance when this wasn't maybe needed for scientific computation and simulation. Maybe the cloud wasn't particularly interested in optimizing their data centers for that. But now it's kind of deep learning needs that, and so they had to do that. And scientific computing is kind of benefit from them as a byproduct. So I'm very happy about that. But yeah, and this is nice. So this is some point to point, but also from an application point of view. So this is the N-body simulation, and N-body is a compute intensive job, not much communication. So the cloud is doing very well, but that's kind of expected. That was like this also few years back because the nodes were more powerful maybe. But what's interesting is for the FFT, that is a very communication and memory intensive application, this specific cloud instance is doing way better than, well, arguably way, but better than supercomputers. And this is something that had never happened in the past. So that's exciting. Okay, let's see if this, okay, it's still in a runnable state. So I think at this point we might just call it, okay, now where is this? Okay, this one. Okay, so you just remember to delete everything. And so I think I'm mostly done with what I wanted to go through. And as you can see on the tutorial, there is a whole appendix part with most of David's work that he did on the previous version of this tutorial. So there is a whole part on billing, and many of you might be interested in this example on aligning RNA data, and also this common interface, how to use Jupyter and Python on AWS. If there's any question in 1 minute, or otherwise there is my email at the very end, and I'm very happy if people have questions or want to learn more about this.
Awesome. Well, thank you so much, Giulia. That was really, really a lot of information. And I feel like this is a great resource. And I learned a lot about how to do like the parallel computing on AWS. I'd never really had such a great tutorial on that. So
Great.
yeah, I just want to say thank you so much. Before I open it for questions, I did want to just remind everyone that we have this little form that we'd love for to fill out. If you have a chance, I just sent it over this chat. But yeah, that's my only announcement. Any questions? I'm happy to stay on and as people ask them. There's one question right here. Could you comment on how GPU computing is done with AWS?
Oh, you basically just, it's very simple. You basically just choose instances that have GPUs on them. So it works the same way. Is that like when you will log in into the instance, you will have your GPU, and that's the same way that using your GPU on your local cluster or anything. And again, you might have to choose between different GPUs, and yeah.
Is it the same stage as when you were choosing an operating system to use, or is it after that stage where you choose like the specifications on the hardware?
No, it should be at the specification of the hardware. So let me check. It should, oh yeah. I think so, for example, so instances type. Let me see if I just do this. Okay. I don't know, 2. Okay, yes. There is a, when you like look for instances type, you will just pick one with GPUs. And there's also FPGAs or different kind of hardware. But yeah, it is at the instance type, like level.
Awesome. Yeah, that is helpful. Yeah, and so you can choose different memories and different GPU combinations.
Yeah, again, you always have to pay attention at the multi-tenancy stuff. So if you want to use all the GPUs, make sure that you select to, having the dedicated instance or anything. Yeah. That's often happen also on local clusters, like on Core we don't like by default don't share like CPU nodes. Those are like dedicated, but for the GPU nodes, those are like by default shared. So if you want to use the whole node, you have to specify that you want the whole amount of GPUs on that.
Yeah. If for someone who's just getting started with high performance computing, which scheduler would you recommend? So I know you said you like Slurm, but is there a reason why someone who's just getting into it would choose one or the other?
Oh, no, I think it's really up to the person. Like, I always use Slurm because that's what we have on the supercomputer. So I'm just more familiar with that. But if someone, is starting from scratch, it's probably just a matter of taste. Yeah, I don't personally, I don't think there's one better than the other. Like, I think Slurm is less intimidating from, point of view because that AWS batch seemed like crazy. But it's also a little bit more annoying because you have to specify, every time that you log into your cluster, you have to check your host ID and compute ID, like IP, sorry, and manually set them in your command line. So it's maybe less intimidating, but more annoying in the long run.
Yeah.
And this is for interactive job. Like if you use batch job, that might be less annoying.
And then one more question. So you used a config file when you were setting up your high performance computing environment. Could you show us what those config files look like? And are those created automatically or do you create those yourself?
Those are created automatically by the parallel cluster framework, but you can modify them. So config, for example, 1, I think. So this is what it looks like. You will have different parts in your config, and you have the region, the cluster type, and all the like subnetwork information, and this usually is just created automatically. And this is the key name. And once you created this, if you decided to change your key from Sarizo, you can manually change this. You can manually change the scheduler or the type of instance and the numbers. There are a few more parallel cluster. That's not exactly what I wanted, but okay, this is like, anyway, there are a few more options, like for example, the placement group that I mentioned earlier. Like what you might want to do is in the cluster default, add something like, I don't remember exactly like if the syntax is correct, but something like this. And so you will tell to use the cluster. Or here you can force the initial state, like the initial number of instances instead of giving it up to them or something. So it's way less intimidating than I thought it would be at the beginning.
Yeah, that's clear. Yeah, taking a look at what's inside of this, I think, demystifies it for me at least.
Yeah, yeah, not totally. Config file seems like something very weird, but this is pretty clean and pretty nice overall.
Yeah. Yeah, well, those are all the questions that I saw come in, but yeah, as you said, your email's on there. So I guess if anyone has any other questions, they can reach out to you.
That's great. Yep.
Awesome.
Hope it was helpful.
Yeah, well, this was so helpful again. Thank you again, Giulia. And next month on March 11th, we'll be hearing about how to use PyTorch and building a variable autoencoder as an application. So hopefully you all can join us for that. But if not, thank you for coming to the first one of the semester, and let us know what we can do in the future, what topics you're interested in by filling out that form I sent out. Yeah, cool.
Thank you very much.
Thank you so much again. Yeah.
Bye-bye.
See ya.